Hi, my name is ManikaRaja, and I'll be presenting a final project on harvesting, storing, and retrieving data. As part one of my project, we'll be presenting a big data strategy to be used in telecommunication industry. With the increasing adoption of smartphones and growth in the mobile internet, telcos today have access to exceptional amounts of data sources, including customer usage pattern, location data, apps download. All this data together becomes big data. Telecom companies must find the right solution to store all information available across the organization to maximize revenue using the analytics. Big data has the potential to place the telcos in a position to win a battle, to earn more customer and create new revenue systems. It provides them with a wealth of information about their customer behaviors, preferences, and movements. With big data analytics, the service provider can utilize the full potential of their dataset by correlating, processing, and deciphering the hidden information from it. The conventional machine learning tools without big data are becoming inadequate as the trends shift towards distributed and real time processing. The usage of smartphones, internet broadband, and peer to peer traffic, social media, Internet of Things contribute to the data volume and bandwidth consumption. The internet usage pattern and demand has changed. The explosion of information is mainly driven by consumers. Telcos have been exposed to their bits of data based on their large subscriber connected to the network every day. By extending their voice to customer service into business, they are now capturing more and more data. This activity leads to big data characteristics from machine logs, internet activities, and usage of customer mobile phones. Machine learning is important by supporting data scientists to solve computation problem efficiently. By combining big data and the machine learning techniques, it is potential to exploit what is hidden inside big data. There are several definitions of big data, but based on literature, the best approach defining big data is by characterizing it. Three key features, or three V's as they call, of big data are as follows. Volume, determined by the size of data. Velocity, as described as the rate of data flow of fresh data continuously in a real time from various sources such as sensors and machine logs. Variety, as defined as various data formats which is coming from different data sources, for example, structured, unstructured, semi-structured audio and video. Comparing conventional approach and Hadoop approach, working with larger dataset is conventionally possible where traditional approach only a few percentage of the dataset actually can be used for data modeling. The limitation is due to the cost of proprietary machine storage and computation. Most of traditional database resides on a single machine. For example, the conventional database or RDBMS finds it challenging to handle huge data volume. It needs to be upgraded by adding more CPU and more memory vertically. Big data is generated at high velocity and mostly in an unstructured format. The unstructured format typically is a text heavy but may contain other information such as number and dates. RDBMS is not designed for this purpose. It only has single query engine which only can implement on its database schema. It works best with structured data such as financial data. Hadoop is an open source framework for distributed data processing and storage using the MapReduce for big data structure. MapReduce is a programming model of Hadoop for large-scale data processing. Hadoop is designed working with various type of engines for particular data processing model. For batch processing model, MapReduce is suitable for handling huge data sets when processing time is not factor. For interactive queries which require a faster result, Hive on Spark is a suitable engine for this task. real-time data set such as machine logs, live streaming data, and high throughput capability of live data stream. In conclusion, the service provider should take into consideration Hadoop-based approach. The selection of the right data processing engine is dynamic and beneficial for many use cases inside the telecommunication industry. Big data analytics platform tools have the capability to correlate to any trends and association. It is a cost-effective approach without any data conversion into a structured design similar to conventional data warehouse, which only suitably executes the legacy analytics that is sluggish and has a limitation. The table below shows a comparison. As we see, we big data analytics improve on our cost, speed, time, discovery, volume. Moving forward to the telcos use cases, big data demonstrates the capability to centralize all the information for automated data processing and advanced analytics with machine learning. Examples of big data use case in telco industries can be described as network infrastructure. Network capacity planning utilizes big data and machine learning to optimize the rollout of new service coverage. Service and security. CDR's use case in telco utilizes big data analytics platform to detect the pattern in any dropped calls and low quality voice. Sales and marketing. Telco interact with their customers across many channels over time. It is a very challenging task for them to correlate the customer activities when the historical interaction records are stored. Business. From the telco business perspective use case, it is concluded that new product development is important for providing new value to the customer. Big data as a shared service. Hadoop implementation typically begins with analytics application. The use of Hadoop can be a complement of existing data system because of its low cost storage price, data processing power, and scalability. With the continued growth of analytics application and data, the concept that Hadoop becomes a data lake starts to materialize. Hadoop as a data lake contains all data, including processed and unprocessed, in the same location. It allows users across business dataset to define, enrich, and explore the dataset by preference. The speed of provisioning reduces the operation complexity and harness the learning curve for the end users. The enforcement of data security, privacy, and government inside the data lake are consistent. The convergence of big data and telco industry is shaping the future of telco on how to drive business value from data analytics capabilities. Digital era has moved from data accessibility from batch into real time. The capability to access large volume inside big data platform helps the data scientists to produce meaningful analytic results. Big data analytics platform has enabled the data scientists to work with a massive amount of data set without restriction. Thus, many telcos have moved from hypothesis-based towards data-driven approach. Big data platform enables the environment which encourages data discovery. As a result, telcos now can move faster, do more experiments, and learn quickly. Now they can load all the data and let the data tell the story. Thank you. We will continue in part 2 of the presentation on another video. Thank you.